Oh boy. Oh my gosh. Guys, I'm so exhausted. But we are here to learn. We are here to learn. And that's the most important thing. The more you earn. So that's what we're going to do today. We are going to keep building out the foundation here about learning Python. And I was actually going through another course too. This is a complete side note. Just the importance of running through fundamentals like this, right? Is like we're going to learn more and more important, just baseline level things that help us build more and more robust software. So there's even another course here. It's a JavaScript course in Alchemy University that I think I'm going to run through as well, doing this kind of style of teaching where it's like, hey, I've obviously got a lot of experience in JavaScript. I've worked professionally with JavaScript, but let's also make sure that because I was even going through it, I was like, linked list, I could probably brush and like learn more about it. Merkle roots, I could definitely learn more about, like things that I don't have full things on. I want to really have the fundamentals fleshed and honed out, most importantly, because I did work multiple positions, right, with JavaScript and TypeScript. And I'm like, like if I could get even better at it, right? Similar thing with Python, what we're doing here, where it's just like, if I could really just hammer out the fundamentals, that's the most important part, because the fundamentals is what builds everything. Like if you have the fundamental building blocks, you could literally build everything. So this process seems kind of boring. It seems kind of like, why are we learning the fundamentals? What's all this stuff about? But it really does add up. And I'm just speaking from experience again, because when I like learned React, I was like really focused on the tiniest bits about it, and it really, really paid off hugely for me. So just doing a similar thing now with a few other tiny things, right? So let's dive in. Let's dive in. So abstraction. Abstraction is one of the key concepts of object-oriented programming. The goal of abstraction is to handle complexity by hiding unnecessary details. You can see abstraction and encapsulation typically go hand in hand. And if we aren't careful with our definitions, they can seem like the same thing. So encapsulation sounds very similar to this. So while definitions are always changing, I like to think about abstraction and encapsulation in the following way. Abstraction is a technique that helps us identify what information and behavior should be encapsulated and what should be exposed. Encapsulation is the technique for organizing the code to encapsulate what should be hidden and make visible what is intended to be visible. If you want a longer read on the topic, check out this. So let's see. Abstraction is a technique to help us identify what information and behavior should be encapsulated and what should be exposed. Encapsulation is a technique. Did they mean abstracted here? Which behavior should be abstracted? I guess I'm not doing the best understanding these two definitions here, but let's see. Organize and encapsulate what should be hidden. Okay. We'll just keep going. I'm sure it'll kind of make more sense as we do this. So are we encapsulating or are we abstracting our code when we make private data and methods? Both. Almost always we're doing both. The process of using the double underscore is an encapsulation method. The process of deciding which data deserves to be hidden behind the double underscore is an abstraction. Let's look at an example. Okay, cool. So we have a bit of an example here. We got import random, and we're getting a random number between 1 and 5, or 0 and 5. In this example, we're using the random library to generate random numbers. As it turns out, it's kind of a hard problem to generate random numbers. This operation seems, or this operating system actually uses the physical hardware state of the computer as the input to seed the randomness. However, the developers of the random library have abstracted the complexity and encapsulated a lot of the data and behavior, so we don't have to worry about it. We're just like, just make a random number for us. However you do it, do it. Okay, so this is how it would do a random number from 0 to 4. And the decision to take a single input as the random range function is a decision of abstraction. Okay, so that's starting to understand a bit of the abstraction, kind of what we're exposing to the user, it sounds like. So that makes a bit more sense. What's deciding to be encapsulated and what's not. That does make a bit more sense. Okay, so when writing production level software, getting the abstractions right is crucial, because they are the hardest things to change later. Think about the consequences of that random package maintainers changing the input parameters of the random range function. It would break code all over the world. So just for instance, if they're like, oh, you actually need to have 2 parameters. So instead of just 1, you also have to have the beginning number and the end number, which they honestly kind of should do in my opinion, but that could be an example of adding a parameter that would change everything. So, okay, so a human class with a constructor has already been created for you. we don't want the other game developers using our human class and to worry about how, or excuse me. So we don't want the other game developers using our human class to have to worry about how the humans move. We'll abstract that data away from them by encapsulating the private position X and position Y and speed variables. Let's just add methods as the user will usually call them. So we have a move right method, move left, up, down, so on and so forth, and then get the position. So what do we need to do? What do we need to do? I imagine move right, move left. We'll do self add one, right? Adds the human speed to its position. Got it. Okay, so we'll say self dot position X plus equals speed, right? Move left would be the minus equals the human speed, and then move up, it'll be this, but just for position Y. Move down will be this, but for minus position Y. And this returns a tuple of self X and self Y. So let's see, so self X and self Y. Let's try. Nope, did not work. Oh, self.speed, oops, that's not gonna work. We just did speed here. I can't select all of them at the same time. Oops, okay, so here we go. So boom, 1, 2, 3, 4. All right, let's try. Nice, cool. So, okay, so that makes sense. So we're just showing these methods where the human or the other developer using this human array can then make a class called them. I don't know if they're making a human named Ryan, right? Like it's a human, and then put in all the parameters here of like position X, position Y. So maybe it starts at 0 and 0, and then speed of 1. So then I could say Ryan dot move down, and this would be how to invoke that function. So I don't have to worry about all this. I just need to do this as a developer. So just instantiate the class, and then I can trigger whatever commands I need, right? Just like this. That is my rough understanding of this abstraction and why it's so important. So let's keep it moving. Let's keep it moving to the right. So blank is a technique for hiding data and behavior. I'm going to say encapsulation. Sweet. Blank is a technique for designing an easy to use interface for complex behavior data. So we're going to go abstraction. Woohoo. All right. So sprint. Let's add some abstract features to our human class. In the game we're making, Age of Dragons, humans could sprint, allowing them to move twice as fast. However, sprinting requires stamina. Each time a human sprints, it loses stamina. Once it's out of stamina, it can no longer sprint. Seems like a good sprint function, right? So complete all the missing methods. So raise the if cannot sprint and, okay, so here sprint stamina are private methods that are only intended to be used within the class. In your case, you'll use them to build these other sprinting methods. So we're going to need to call these to check, imagine if the person can sprint or not. So let's see. So this raise if cannot sprint should raise the exception, not enough stamina to sprint. Let's see, raise exception. Let's just get it down right now. Not enough stamina to sprint if the human's out of stamina. So we'll figure out what that needs to be in a moment. Okay, so use sprint stamina means we need to, oh, I had these backwards. Okay, so this one right here, use sprint stamina, we need to remove 1 stamina from the human. So where's the stamina being passed in? Boom, there it is. Okay, so they've instantiated that class for us. So let's go ahead and steal this. Or not that class, but that property. So let's see, boom. I think that'll work for that. So it just uses 1. And then we'll say if stamina equals 0. We'll try that, right? Seems to be the appropriate logic for the stamina deal. This is great, by the way. I like breaking things down this granularly. It's so cool because I don't know. It just like feels like we could build a game potentially. You know, like actually figure out how to do this and break it down programmatically one step at a time. Like, oh, how do we add a stamina function? Boom, we can leverage just this bit of knowledge of like, oh, it's really that simple. Okay, cool. Okay, so let's see. So the remaining methods. So all of this stuff, the sprint right, sprint left, I think is just going to, I think it's just this, right? Sprint right and left times 2, right? Is that what we saw? Move twice as fast. Yeah, that is what it is. Correct. Okay, so self.speed. And this will be the Y method. Okay, cool. So I think that's about right. We just need to get these in the correct order. So raise an air if there's not enough. Let's see. Use the stamina needed to sprint. I think this will be needed in every single class. So, but we can raise the cannot exception. Oops, did not want to see the solution quite yet. So we can actually use this raise if cannot sprint, I believe, in this guy. So use stamina. We could probably say self dot this. That way that's handled, right? So this logic is already handled between these two methods. And then for this, I believe we just need to say self. For the rest of them, right, we just need to trigger, I think, the stamina class. Let's see. We got some passes, we got some fails, not enough stamina to sprint. Okay, but we're almost there, which is great. So we passed actually one of them, which is so cool. So 4 passed, 4 failed. Let's see. So accept actual not enough stamina to sprint. Oh, did not spell sprint right. Well, that'll do it. Oh, that's all there was. Okay, we forgot a T. We forgot a T. You know what they say, I was dot the I's, cross the T's, right? So, okay, so OOP is typically blank data and behavior. I'm going to say groups, data, and behavior. Object-oriented programming language typically groups data and behavior or separates data and behavior? That's a good question. That's a great question. Let's read this. So how OOP developers think. As we saw in the last exercise, variables can be private, but methods can be private as well. In other words, we can encapsulate behavior as well as data. Grouping data and behavior. Classes and object-oriented programming are all about grouping data and behavior together in one place, an object. Object-oriented programmers tend to think about programming as a modeling problem. And they think, how can I write a human class that simulates the data and behavior of a real human? We aren't focused on functional programming in this course, but to provide some contrast, functional programming tends to think about inputs and outputs. When a human acts, what are the inputs and outputs of that action? How do the outputs affect my program state? Okay, so that's kind of two paradigms of thinking, right? So like on object-oriented side, if I want to build a class of a mouse, I could start doing things and say like, okay, let me build out the class of this, like the texture of it, maybe its functionality, can scroll, can't scroll, has like buttons to click, has Bluetooth wireless connection, like all these other tiny things, and all these properties inevitably across, you know, and you could actually, from a data standpoint, build this mouse out, right? From like has rounded curve, has, you know, thumb holder thingy, but it would be a ridiculous amount of methods. But for in short, we could have like 3 of them, right? And you could have all these properties and things that would actually construct this mouse. So that's kind of like the object. Is like, here's all these things that would define this thing, right? This real life object. And from my understanding, functional programming is kind of like you're almost like inside of the frame of trying to define the object. So you're like, oh, if I press the scroll thing, what does that do? But maybe that's not like definitive for the mouse. It's just like it's thinking, I think just more like functional, I guess. So functional programming, right? So I don't know. In my brain, object-oriented programming makes sense because I think of everything in JSON objects when I look at programming now, and it just helps. It just helps my brain so much to understand it. So, but I don't really understand the granularities of functional programming. So okay, so here we have object-oriented programming developers generally think of program as a problem of modeling. And I really like that paradigm as well, because object-oriented programming it's like taking a big object of a problem, and you just classify. You're like, okay, now I have smaller problems. And then even within the smaller problems, you can now take that and unpack that. Like, okay, now how do I build this thing with this smaller problem? Let me break it into little bite-sized problems, like we just saw with the stamina and sprint. If we were building a game called like 2K, right, or Skyrim, and you could sprint, we would look at it and be like, holy crap, there's so much stuff to do in 2K. I got to do stamina, I got to do jump shots, I got to do 3-pointers, I got to do all this stuff. There has to be cool game graphics. Like, but when you break down the logic and like how the player moves and stuff, you're like, oh, hold on. Maybe it is just these tiny steps that I have to figure out. So that's why I think of, I don't know, I'll have to learn functional programming a little bit more, I think, but to make a full statement. But I personally enjoy object-oriented programming very much. So complete the calculator class. Create a private instance variable called result in the constructor. So let's say self.result equals 0, or we'll do this. I always like to do this. personally, but tomato, tomato. Or I guess technically we could maybe do that in Python. Would that work? Maybe. I don't know if that would. I don't know if that would. Okay, we'll keep it basic. We'll do it basic. Okay, so boom, math. The following methods should perform their respective mathematic computations. The left-hand side of each operation should have the current value of the result variable. Hold on. The left-hand side of each operation should be the current value of the resultant variable. What does that mean? What does that mean? The right-hand side of each operation will be the value passed in. Okay, so self.a, subtract.a, multiply.a, all that stuff. So if the user attempts to divide by 0, raise value error cannot divide by 0, all that fun stuff. Okay, so let's just go ahead and get those error exceptions in there. So raise value error, copy that text, cannot divide by 0, and let's see. So we'll say if a equals 0, boom. Okay, and then what is power? Is power, that's a square root deal? No. Okay. So I think I could say self.result plus equals a would be that one. Subtract would be this minus a. Multiply would be this one times a. This one would be divide by a. Modulo, that's a fun one. Would this actually work for the modulo sign? We'll see. We'll see. We'll see. And how do you do this? Is it that? I believe. And square root. Yeah, I think that's actually square root. Okay, so let's see how to do the power and clear. I guess it would be self.result equals 0. Imagine and get result would be return self.result. Okay, let's see. Result attribute is not multiply. Boom, boom, boom. Let's see. Taking it to the old chatter GPT real quick. Just because I don't know the syntax for the modulo, I don't know if this will work. If we have to say equals 0, something like this. And same with the power. I don't know that. So power function method uses this. You should use this is the power function. But then what's the square root? What is the square root? Okay, let's see. So that actually does work for the modulo. That's cool. That is cool. So power is that, and then the square root is self-result. Oh, interesting. That's the square root way to do it. Interesting. Okay, and then it says I need to return a lot of these. So return. Interesting. Does not work. I can't do that. What do you mean? All right, let's not do that then. Let me put all these return statements here. See if that will do the job. Guys, I'm super excited to do the, what's it called? The EVM stuff. I think that's going to be really, really, really fun. Okay, so that's what we just did. It didn't work. It didn't allow all the return stuff. Okay, so that's out. So result equals 0. Boom, boom, boom. Self result. Oh, it's underscore result. Oops, forgot the private variable deal. Well, that'll do it. That'll do. Keep doing these parentheses. I always forget. Okay, boom. And that's that. What about this one? Boom, bada bing. Okay, we're off to the races. Challenge 2, deck of cards, guys. And then we are wrapped up with the abstraction section in Python. Super fun. Okay, this is exciting for me because we're just about done with this this kind of course. Oh, we're gonna do inheritance next, which is really fun. Then some polymorphism, which will be a good time. And then we're on to building the book bot and off to the races, continuing the race. Okay, so deck of cards. A close friend recently contacted you because he knew you could code. Very typical. I've got an idea. Can you code this? Okay, so his family enjoys playing card games, but their toddler keeps getting into the card drawers and damaging all their playing cards. He asked if you could write a program that could create a deck of cards that they could use instead. So challenge, finish the deck of cards class. The suits and ranks of each card have been provided for as your class variables. So right here we have our hearts, diamonds, and spades, and then all of our numbers, if you will, or ranks, I suppose. And our job is to build a constructor with an empty list called, sort of empty private list called cards. So we can initialize that as a list. Fill the empty list by calling the create deck method in the constructor. So, okay, so we can say self.create deck. So that should roughly work. So it instantiates the first deck. Then we need to build the create deck function. So this method should create a rank and suit tuple for all 52 cards in the deck and append them to the cards. Okay, so we can say return, let's see, self dot, we want rank and suits, I imagine. So how is this going to work is the question. So we want one rank, one suit for one card. So create a deck of cards. Let's see. So let's think about it programmatically. We need to loop through this. So we need to loop through the hearts or the suits first. One or the other. I think either way we do it, but we need to say for suit in suits. So we need to loop through. So we start at hearts, then we need to make a ace of hearts, 2 of hearts, 3 of hearts, 4 of hearts, so on and so forth. And then when it's done going through all the ranks on hearts, swap it over to the diamonds, and then make an ace of diamonds, 2 of diamonds, 3 of diamonds, go all the way through. When it's done with that, swap it over to clubs. I think that's roughly good idea, right? So for suit in suits, let's say for ranks or ranks in ranks, return, or not return, but self dots. What would it be? Self dot cards. We want to append the tuple. So the tuple will be the suit, right, and the rank, I believe. I think that's all we need, right? Suit and rank. I think that'll run through all of them for us. Just that logic alone. I hope. Fingers crossed. Fingers crossed. Okay. I think this actually needs to be a tuple like that or something. Okay, so let's see. So order matters. The cards should be appended in the list of the following orders. All ranks of hearts. Then, oh, we got it. We got that part right. Nice. Just off the hip, we got that part right. That's awesome. So with each suit, the cards should be ordered from the lowest rank to the highest rank. So shuffle deck self. This method should use the random.shuffle method available from the random package. So import random. There we go. And we can shuffle the deck of cards. Now, I'm not sure how to do this with the card deck. So if we say random.shuffle, and do we just pass in the self cards? Would that actually do it? I don't know. Let's see. So then deal card, this should pop the first card off the top of the deck. So let's see. So we'll say self.cards pop. Okay. Top of the deck is the end of the list and return it. If there are no cards left in the deck, the method should return none. If self.cards, we could say if length of self.cards, right? So this length self.cards equals 0, return none. Else do this. Cool. Let's run it. Let's see. So for suits and suits, why is that not? Do we need to instantiate the suits here? I thought we'd just be able to pull that in, right? So suits, rank. I feel like that should work, right? So line 26 create deck. Let me get this out real quick. Boom. Okay, so I think it was something to do with this. So self.create deck. Can we just do that maybe? Self.create deck. Maybe a pass in self is what it needed. Takes one positional argument, but 2 were given. Interesting. We're going to pass this jibber jab, all this stuff in. Let's see. No. Okay, folks, we're gonna take a little peek-see at the solution. See what's going on here. Okay, so deck suits, create deck. That's what we had originally. It did not work. We had to say self.suits. Okay, but we got it right. That's amazing. That's so amazing. Look at that. So you still have to say self even with this, even though it's like an open variable. Okay, so we got that bit roughly correct, right on the head. For suit and suits, for rank and ranks, self.cards append. Nice, we crushed it. Oh, I have them backwards, but I don't know if that would actually matter. I don't think it would, because you would know it's an ace or diamond. You could say diamonds of ace. Technically, we all say ace of diamonds, but you would be able to identify that the ace is with the diamond or the diamond is with the ace. Either way, Okay, so shuffle deck. Looks like we got that one down pat too. Then if length of cards, self.cards equals 0. So we have that, return none. If not self.cards.pop. No, that looks all proper, right? If length, self.cards, yeah. Yeah, so I don't see why so we have for suit and self suits. So that should work, right? Self.cards append the suit. And yeah. And for dealing the card, we have if the length of self.cards is equal to 0, return none. So do that, which we've done. Let's do return self. Boom. Okay, there we go. There we go. Nice. Nice. Okay, it took us a little wrestling, but we got there. We got there, which is awesome. It's super fun. So again, another thing where it's like it's fun to see that these things that I think outside looking in, if someone had said, "Oh, build me a blackjack game," obviously a deck shuffling deal is going to be part of it. And I would sit there initially and be like, "Gosh, that might be a little bit complicated." But now that we're like really granularly through object-oriented lens, like breaking things down one baby step at a time, it's like, oh, it's really hopefully not that bad. You know, obviously there's a little tweaking that needs to happen, but you know, I think with like a blackjack game, we would just now need to develop the game rules on top of this. But any card game, this is all going to be part of it. So let alone just like any game in general where you're like instantiating the rules of something. So it just helps where I don't know. I like it. I like it. I like it. I like it. I like it.